This is Atlas Launch Control at T-minus 2 hours and holding. We're now considering the built-in hold time that we have remaining in our countdown tonight. We're approximately 2 hours and 45 minutes away from the liftoff of NASA's magnetospheric multiscale mission, known for short as just MMS. Launches atop a United Launch Alliance Atlas V rocket from Launch Complex 41 at Cape Canaveral. The launch window today extends from 10:44 to 11:14 p.m., a duration of exactly 30 minutes. This will be the 53rd Atlas V launch. Of those, MMS will be the 12th NASA mission to be launched on an Atlas V rocket. MMS will advance the story of space weather, solar physics, and the phenomenon known as magnetic reconnection. MMS will be the first mission to observe magnetic reconnection with instrument 100 times more sensitive than any instruments flown previously. 4 identical observatories will fly in pyramid formation. Each of the 4 spacecraft, octagonal in shape, is 4 feet tall and 11 feet across once their instrument booms are deployed. They will be placed in a highly elliptical orbit, which ranges between 44,000 and 95,000 miles from Earth, nearly halfway to the Moon. But yet the 4 observatories will fly as close as 6 miles apart from each other. The mission will advance our knowledge of space and solar physics, but yet have some practical applications, such as an understanding the effect of what causes solar storms, and predicting the timing and severity of their effects on Earth, and how best to respond to them. At this time, we're not working any problems in our launch countdown, and will remain on schedule for liftoff at 10:44 tonight. We're standing by now for our readiness poll from our NASA launch manager, Omar Baez, coming up in just about a minute or so. And at that point, we will be preparing ourselves to pick up the countdown. The countdown will resume at 8:14 p.m. Eastern Time this evening. Just prior to that, we'll have a readiness report for cryogenic tanking from our United Launch Alliance Atlas V launch team. And our launch conductor, Doug Lebo, will brief the test team for the launch site on the proper procedure for continuing through the countdown tonight, as far as all of the countdown protocol required in communications with the launch conductor. At T-minus 2 hours and holding, this is Atlas Launch Control.
All stations, this is the NLM on the NLM net. Welcome and good evening for the MMS launch countdown. Currently, all primary range assets are green. Weather is green. The launch vehicle and the spacecraft are powered up. And with that, I'd like to proceed into our readiness for cryo tanking poll. NASA CE.
This is Ace for NASA CE. We are go.
Copy that, Ace. SMA.
SMA's go.
SMD.
SMD's go.
NASA Mission Manager.
NASA Mission Manager is go.
And NAM.
NAM's ready.
Copy that. NASA team's ready to proceed into cryo tanking.
This is Atlas Launch Control, T-minus 2 hours and holding. As Omar Baez mentioned, weather is go. We have an 80% chance now of having acceptable launch weather for our countdown tonight. Just a chance for some cloudiness, which could be a factor, but otherwise our launch conditions are very acceptable for a liftoff tonight. We'll look now at a brief video of the rollout of the Atlas V yesterday, which actually began at 10:01 a.m. yesterday morning. Once the rollout begins, it takes approximately a half hour to complete the rollout. The Atlas V, as we see it there, is 195 feet tall, weighing just under 750,000 pounds, and using a 14-foot diameter fairing. The spacecraft that's on top of the Atlas V consists of 4 of the observatories. Each observatory weighs 2,998 pounds. So collectively, atop the Atlas, the MMS spacecraft on top of the rocket weighs 11,992 pounds. This is a time-lapse video of the rollout to the pad. See the 2 solid rocket boosters attached to the rocket as well. These will create quite a bright flame at ignition and liftoff, which will be excellent for launch viewing tonight. And we're back now with a live picture of the Atlas V on the launch pad at Space Launch Complex 41 at Cape Canaveral. At T-minus 2 hours in holding, this is Atlas Launch Control. This is Atlas Launch Control, T-minus 2 hours and holding. We're preparing to pick up the countdown at 8:14. In just a moment, our launch conductor, Doug Lebo from United Launch Alliance, will conduct the pre-test briefing for the launch team in preparation for picking up the countdown about 5 minutes from now. At T-minus 2 hours in holding, this is Atlas Launch Control.
Pre-test briefing. This operation is classified hazardous. Cryogenics will be loaded, ordnance items are installed, and high pressure and inert gases are in use. Any anomalies will be brought to the attention of the launch conductor. Evaluation will be performed by a support team led by the anomaly chief and the vehicle system engineer on channel 6. Com channel 1 will be the primary command channel, with backup being com channel 2. The following documentation will be in use for today's operation: Test Plan X45-LCCMD-SLC, Plan Revision 33. Order revisions, there are none. PSM document configuration AV053, revision Echo.
And we're T-minus 2 hours in holding. We have confirmation that the eastern range is ready to support our cryogenic tanking operations. Once again, we're not working any problems in the countdown. Our temperature at launch time will be approximately 73 degrees. Winds will be from the east, 14 to 18 knots at the time of liftoff. Just a 20% chance of having a launch weather criteria issue.
Readiness poll for cryogenic tanking. Atlas systems, propulsion.
Ready.
Hydraulics.
Ready.
Pneumatics.
Ready.
LO2.
Ready.
Water.
Ready.
Centaur systems, propulsion.
Ready.
Pneumatics.
Ready.
LO2. LH.
Ready.
Copy. LH2.
Ready.
Has gas.
Ready.
Electrical systems, airborne. Airborne electrical, channel 1.
Ready.
Ground.
Ready.
Facility.
Ready.
RFFTS.
Ready.
Flight control.
Ready.
Instrumentation.
Ready.
COM.
Ready.
Timer.
Ready.
GC cube.
Ready.
Umbilicals.
Ready.
ECS.
Ready.
Redline monitor.
Ready.
Quality.
Ready.
Op safety manager.
Ready.
ULA safety officer.
Ready.
Anomaly chief.
Ready.
Range and weather.
Ready.
Launch director.
Launch director's ready.
Proceeding with the count. Verify count to start at 00:14 Zulu with a launch window interval of 02:44 to 03:14 Zulu.
Roger. Count will start at 0014 Zulu. On my mark, the time will be T-minus 2 hours and counting. 3, 2, 1, mark. T-minus 2 hours and counting.
Pressurize Centaur LO2 storage tank to chill down level.
Roger.
Start Atlas LO2 ground chill down.
Roger.
Start Centaur bottle pressurization to flight level.
Roger.
Start Atlas AHB pressurization to flight level.
Roger.
Pressurize Atlas RP1 tank to step 2.
Roger.
Adjust CISA temperature to 110 degrees Fahrenheit. ECS LC.
Go ahead.
Roger. Adjust CISA temperature to 110 degrees Fahrenheit.
Roger.
T-minus 1 hour, 59 minutes.
Initiate CEC safing purge.
Roger.
Start CEP to high flow.
Roger.
Start CFA purge and displacement mode.
Roger.
Perform vulnerable data transfer to backup CCLS.
Roger.
Configure Davis system cameras for launch.
Roger.
This is Atlas Launch Control, T-minus 1 hour, 55 minutes, 48 seconds, and counting. Joining us now here at the console in the Mission Director Center is Jim Birch. He is the principal investigator for the MMS laboratory and the science instruments that are aboard the spacecrafts. He is from the Southwest Research Institute in San Antonio, Texas. And Jim, I'd like to welcome you and ask you to sort of lead off and explain a little bit to us what magnetic reconnection is.
Very pleased to be here with you, George, at this event. Magnetic reconnection is a process that leads to some of the most energetic phenomena that happen in the solar system, also other places in the universe. And so MMS is designed to solve the mystery of magnetic reconnection, because we understand very little about it. I have a slide here to show. Okay, this shows magnetic reconnection geometry. In one sense, it's very simple, and in another, it's very mysterious. The idea is that there are magnetic fields in opposite directions with a boundary between them. Look at the top, magnetic fields pointing to the left. The bottom part, they're pointing to the right. They're flowing together. And in this box called diffusion region, the magnetic fields interlink. And they're torn apart and connected to the magnetic fields in the other regions, and jets of high-energy particles and plasma are produced. In this process, magnetic energy is destroyed and is converted to particle energy. What goes on inside that box is completely mysterious because no previous missions or even theories using computer simulations are able to look at the tiny scales that need to be looked at, and that's called the electron scale, the smallest scale of the plasma. And so the goal of MMS is to put 4 spacecraft within that diffusion region and understand what makes the field lines interconnect and what makes the magnetic energy get converted to particle energy. Now, there are two regions at the magnetosphere where we know this happens. On the day side, where the solar wind interacts with the Earth's field, and on the night side, where the fields that were open then reconnect again. And this is where the aurora, magnetic storms, and other phenomena are produced. So the video that we have here shows these two boxes, one on the left, one on the right. And there's a computer simulation coming up now that shows what we think is going on in these boxes. What's plotted here are electron currents, and this is one of the latest and most sophisticated computer simulations that we have. And this is the type of thing that allowed us to design our experiment to be accurate. So we have to go in there with 4 spacecraft and determine what's happening, where reconnection is happening. And now we have another video that shows how we do this in orbit. To get the three-dimensional view of reconnection, we need a pyramid-shaped configuration of our 4 spacecraft. We call it a tetrahedron. It shows a reconnection on the night side, producing aurora, magnetic storms. And then here's the MMS. We're trying to hit those 2 boundary regions, those 2 boxes that were in the last visual. And when we're in those regions, we want a tetrahedron or pyramid-shaped configuration. We'll see this develop in a minute. And this is done by very accurate navigation using GPS, which requires a very sensitive and high accuracy receivers. And so the tetrahedron develops in the outer parts of the orbit, and then near the inner parts it moves to just a spacecraft following one another near perigee. That's the region we're not interested in. That's here. And then we go out to the region we're interested in. We maintain a near perfect tetrahedron throughout the region of our interest. And we can vary the separation between these spacecraft from 10 kilometers out to 400 kilometers, looking for an optimum separation that we hope to find.
Well, we know some practical aspects can be derived from this, and what would you say
the biggest is that, as I said, the energetic phenomena in the solar system, like solar flares, geomagnetic storms, are all produced by reconnection. And if you think about space weather, what causes space weather? Solar flares, magnetic storms, producing high energy particles, the aurora. Every one of these things is caused by reconnection. So if we want to understand space weather without understanding magnetic reconnection, we're not going to get there. So that's just the main application. Another is in nuclear fusion. We're trying to make fusion machines to solve the energy crisis by confining magnetic plasmas in a magnetic field and heating them up to fusion energies. And what is one of the main things that is frustrating this attempt is reconnection that happens in these devices. So what we learn may help, at least will inform us more about reconnection that may help these laboratory experiments.
Well, Jim, thank you very much. And I know you're looking forward very much to seeing those observatories come off tonight, because that'll be a highlight for you after, what, five years or more?
It'll be 10 years we've worked on this
Oh,
project.
goodness. All right. So, all right. Thank you very much. And we're now at T-minus 1 hour, 50 minutes, 27 seconds and counting. This is Atlas Launch Control.
T-minus 1 hour, 50 minutes.
LCRF.
Go ahead.
Step 210, Davis system configured for launch.
Roger.
LCECS,
Go ahead.
step 400, payload and CEM ECS have been on GN2 for 40 minutes minimum.
Roger.
This is Atlas Launch Control, T-minus 1 hour, 44 minutes, 6 seconds, and counting. We're about a minute away from picking up with our liquid oxygen tanking operation.
Line chill down complete.
Roger.
And
Start
the
Centaur LO2 tanking.
Roger.
drill down just been completed. We have a go to pick up with the cryogenic tanking of the Centaur.
LCRF.
Go ahead.
Step 340, the FTS cycle test is complete and FTS receivers are secured.
Roger.
T-minus 1 hour, 43 minutes.
Perform Centaur LH2 SPV cycle test. Centaur pneumatics LC.
Go ahead.
Roger, perform Centaur LH2 SPV cycle test.
Roger.
This is Atlas Launch Control, T-minus 1 hour, 41 minutes, 14 seconds, and counting. We're now into loading liquid oxygen aboard the Centaur stage of the Atlas V. And joining us now here at the console in the Mission Director Center is Craig Tooley. He is the project manager for the MMS spacecraft and has been with it for quite a long time at Goddard Space Flight Center in Greenbelt, Maryland, as well as when it came down to Florida to prepare for launch. And he's going to let us see some of what we did to get it ready for flight. Craig would like to welcome you, and maybe you could tell us when we roll the tape here. This kind of starts with your arrival and goes all the way through going out to the pad. So maybe you can tell us what we're seeing.
Sure. Thank you, George. So if we could roll this video, what you'll see is this is the arrival, actually, of the first of the two MMS observatories. We brought them down to the payload processing facility at Astrotech, two at a time, in this large shipping container. And what you're witnessing is the some steps in the unloading of the first pair. You'll see them there wrapped in their protective contamination covers, now being hoisted out onto the work platforms there at Astrotech. There you can see one outside being moved to another building. What you see here is you see everywhere we've gone, we've kept them clean, and that was a purge assembly running, that we keep the instruments that are very sensitive to contamination clean. Now you can see inside one of the processing cells there. And then the arrival of the next pair of MMS observatories. We essentially turned the truck around and came back with the second pair about a week and a half later. Again, lifting it off, you can see them there. The MMS observatories are about 12 feet across, each one of them, about 4 feet tall. That is, of course, without their booms deployed, which you'll see a little bit later in the video. And there you get a nice view of the bottom side of it as we lower that one down, again, onto a work platform. And there it is getting moved, actually when it moved to the building to do the propulsion fueling at Astrotech, which we did in another hazardous facility. And they're moving it into the building and into position. That's a pair of them again. We called those mini stacks. In this view, you can see the solar arrays are covered. You can't see them with the protective covers. And around the top of each one, most of those red covers that you can see are actually protective covers for the instruments, of which each MMS spacecraft carries 25 scientific instruments for a total of 100. And they're a nice view of both stacks side by side as we prepared to first do functional tests when we were there. There you see a solar array coming off and our fixed solar arrays on the side. And this is actually a test of the solar arrays where we did a flash test to make sure all the circuits were still intact after shipment. And then you see here actually preparations for creating the full stack of MMS spacecraft, where that one's now on the crane and being lifted. And Yep. Now you'll see actually the full stack starting to look like the complete configuration that we had when we were encapsulated in the Atlas fairing. Nice view of the spacecraft there. And the folks working up on the lifts as we bound them together. In this view, you see a very nice view of the flight configuration of the stack of 4 MMS observatories, flanked by the 4-meter Atlas fairing, just shortly before it was encapsulated and moved out to the launch pad. A nice view of one of our scientific instruments there, and you can actually see the ULA crew moving the fairings into position. Essentially, the last glimpse that we got of these 4 observatories. We've spent almost 7 years building in preparation for the event this evening. And finally, there you see the fairing closing up. You can see we used the whole fairing. It's very tight. We've utilized almost all the space in that 4-meter fairing, and a nice view of our emblem there on the side of the 4-meter Atlas fairing. Shortly after this, it began its journey. Shortly, you see it there encapsulated. It began its journey to the launch site on this transporter. We actually did it in the evening when there's not much traffic. There, it's being lifted. All 4 observatories in the fairing onto the transport vehicle. And finally here, the evening when it was slowly moved from the Astrotech payload processing facility and to the vertical integration facility, where shortly you'll see it begin to be stacked actually atop the Atlas rocket, which was in the days before this itself being stacked. Here it is approaching the vertical integration facility and moving on in. The MMS observatories, that stack you saw, is about 16 feet tall when it is together in there. And I would remind you that when we deploy the booms out of these already fairly large spacecraft, they are 60-meter booms on 4 sides when we deploy them.
Well, Craig, you talked some about the deployment, and we've got some animation that shows what's going to happen, coming off the rocket. So maybe you could tell us a little bit about this animation we're going to see now.
Certainly in this next animation, and here you'll see what will be just less than 2 hours away. There, the fairing is on top of the Centaur. This fairing separates. There's our stack of 4 MMS observatories. You can see some of the instruments there on the upper perimeter. We are spun at 3 RPM, and this is sped up a little bit, but sequentially spaced by 5 minutes. They are separated from the Atlas upper stage. Here you're going to get a view of the first of our deployments. You see our shortest booms, our magnetometer booms, being deployed on each side. And this will be immediately followed in this video, although this happens in total over the course of the next 6 weeks. This shows you the deployment of those 60-meter wire booms to sense electric fields. So we're spinning at 3 RPM and playing out 60 meters on 4 sides of wire booms. And then finally, in our spin or axial direction, you'll see we erect a 15-meter collapsible boom, which also does electric fields. Thus, with these both in our spin plane and at our axial direction, we get a complete 3-dimensional picture of the fields that we're sensing, as well as the magnetic fields on the other booms. And in this last, as you see this, you'll see a little bit of artistic license as you see all 4 observatories in their formation. As Dr. Birch talked about a little earlier, we fly them about 10 kilometers apart.
Well, after we have that deployment tonight and you're on headset and you're listening, what's the main thing you'll be listening to hear from your test team that's happening that lets you know that things have gone well?
Well, actually, we will be communicating with the satellites as we're riding the Centaur. We will get telemetry, so we know they're still as healthy as they are now as we wait for launch. Then as they separate, we sequentially turn on that transmitter and talk to the TDRS satellites and ascertain that we're completely healthy, and we begin getting ready to actually use the propulsion system in about a day to trim out the perigee, the orbit, and such. But we'll get an initial within minutes after separation of each one, and we do that after about an hour and a half on the Centaurs, that we're in good shape.
Well, Craig, we'll look forward to having you back after we have the separation of the observatories to just kind of tell us how it all went. So thanks very much.
Thank you, George.
Good luck tonight. Thank you very much. We're at T-minus 1 hour 33 minutes and counting. This is Atlas Launch Control.
tank to chill down level.
Roger.
Step 400. CFA purge has been in displacement mode for over 25 minutes.
Roger.
This is Atlas Launch Control, T-minus 1 hour, 32 minutes and counting. The next activity to begin here in the countdown is the liquid oxygen going aboard the Atlas stage, the liquid oxygen tanking for the Atlas first stage booster that will be starting here in about 2 minutes, and we'll hear that from our launch conductor as that gets underway. At T-minus 1 hour, 31 minutes, 36 seconds and counting, this is Atlas Launch Control.
CLO at 40%.
Roger.
T-minus 1 hour, 30 minutes.
This is the LC on channel 1 with a comm check. SMD.
SMD has you loud and clear.
Roger. DSMD.
DSMD copies.
Roger. MLD.
MLD copies.
Roger. NSC.
Now C hears you loud and clear.
NSC
Roger.
hears you loud and clear.
I'm sorry, repeat.
NSC hears you loud and clear.
Roger, NSC. NLM.
LC, NLM has you loud and clear.
Roger. NCE.
Yeah, this is NASA CE. I read you loud and clear.
Roger. And comm checks are complete.
LC Atlas Pneumatics.
Go ahead.
Step 390, RP1 pressure decay test is complete and RP1 tank is stable at step 2 pressure.
Roger.
ECB stable at prefill.
Roger.
RD-180 has been on heated GN2 for 20 minutes minimum.
Roger.
Atlas LO2 ground chill down is complete.
Roger. Start Atlas LO2 tanking operations.
Roger.
CLO 50%.
Roger.
Centaur LH2 storage tank at chill down pressure.
Roger.
LDRC-1.
This is LC on 1.
LC for tonight's MMS launch operation. We have one range safety COLA closure period of 03:10:00 through 03:11:00 Zulu.
Roger.
CLO 60%.
Roger.
T-minus 1 hour, 25 minutes.
Adjust CISA temperature to 140 degrees Fahrenheit.
Roger.
CLO at 70%.
Roger.
This is Atlas Launch Control, T-minus 1 hour, 23 minutes, 36 seconds and counting. As we heard, the Centaur liquid oxygen tank is about 70% full at this point. Our next filling operation will be for liquid hydrogen going on board the Centaur. Right now they're preparing to chill down the transfer lines, and then the engine chill down process is next before actually starting the loading operation of liquid hydrogen. That's to chill condition the cryogenic lines and systems so that they don't see such a thermal shock when the cryogenic propellant hits the lines and the engine systems. And a confirmation now that the Centaur engine chill-down process has started. We're going to look now at a short video of something of what the MMS mission is all about.
Understanding vast forces in space and how they affect life here on Earth requires comprehending what's going on out there. NASA is planning to launch 4 identical spacecraft that will orbit the Earth through the dynamic magnetic system surrounding our planet, studying a little understood phenomenon called magnetic reconnection. Magnetic reconnection is unique to plasma. That is, the mix of positively and negatively charged particles that make up stars, fill space, and account for an estimated 99% of the observable universe. On October 28, 2003, and again the following day, massive solar flares erupted on the Sun, sending X-rays zooming through the solar system. Along with the flares, the Sun expelled giant clouds of solar material called coronal mass ejections, or CMEs. The CMEs slammed into Earth's magnetic field and pushed material and energy in toward Earth. This created what's called a geomagnetic storm that can interrupt the work of satellites we have come to depend on.
So you can think of it as kind of like a magnetic explosion. And the reason this is important is because these explosions drive a lot of the weather patterns that we see in the magnetosphere, and so what space scientists like to refer to as space weather.
NASA's magnetospheric multiscale satellites, or MMS, should help scientists understand and better predict space weather patterns.
The MMS mission is a mission consisting of 4 spacecraft which will fly in close constellation to measure a process called magnetic reconnection. We need to measure reconnection in more than one location. We need to measure it in basically how it varies in space, how it varies in all 3 spatial dimensions.
Scientists want to know exactly what conditions, what tipping points, trigger magnetic reconnection events. Much of what we currently know about the small-scale physics of magnetic reconnection comes from theoretical studies, computer models, and laboratory experiments. Better understanding requires observing magnetic reconnection up close. So MMS will make its measurements in Earth's magnetosphere an ideal natural laboratory in which reconnection can be observed under a wide range of conditions. But before MMS and its science team can begin their studies, the satellites must be prepared for launch into orbit.
Once they arrived, several things had to be done. They had to be fueled, they had to be processed down here, and remember there's 4 spacecraft, so it took 4 times the effort.
NASA's Launch Services Program has extensive experience preparing multiple probes for liftoff on a single rocket. In September 2011, the Grail mission sent 2 spacecraft to the Moon. More recently, the twin radiation belt storm probe satellites were launched in 2013. But with MMS, there are 4. Omar Baez is the MMS launch director for the Launch Services Program at NASA's Kennedy Space Center in Florida.
Yeah, it would be simpler to do 1 spacecraft, but we're here to do the difficult things, and that's why this business is so interesting.
As NASA's launch manager, Baez oversees integration of the satellites with a familiar rocket, the Atlas V.
The Launch Services Program contracts the launch service to United Launch Alliance, and this has been a team that has worked together since the inception of the Launch Services Program here in 1998. We work very closely with ULA from the very design of the mission, or from the very contracting of the mission, through the design, through the integration, and finally through the operations and buildup of the launch vehicle and final launch.
Once in orbit, the next challenge is deploying all 4 MMS satellites.
To get them in the right orbit and the right place is a complicated flight design challenge that our team has had. Amazing amount of maneuvers we have to do with the Centaur upper stage to make sure we release all 4 of the spacecraft at the right timing. It's a 5-minute intervals between release. So if you can imagine, that first one pops off, and then the second one 5 minutes later, third one another 5 minutes, and so on.
After months of testing, the quartet of MMS satellites will be ready to go to work.
Once they're commissioned after that 6-month time frame, they formation fly in a tetrahedron formation, and they'll go around the Earth to pick up this reconnection event that we find on both sides of the Earth, where the magnetosphere of the sun's magnetic field and the Earth's magnetic field meet on the sun side, and then on the tail side of the magnetotail of the Earth on the dark side of the Earth.
The spacecraft fly through such a site. They will measure the magnetic and electric fields present, as well as the movement of particles.
We need to understand both of those if we want to understand how the magnetosphere works, and we believe that both of those scenarios are also very important for other applications, such as on the Sun, in the solar wind, in planetary magnetospheres, and in many astrophysical objects, as well as in the laboratory.
During its first phase, MMS satellites will travel through reconnection sites on the Sun side of Earth. During the second phase of its mission, MMS will observe reconnection on the night side, where that connected field flows around both sides of our planet to a second reconnection point.
On the day side, basically you have a situation where the solar wind is just constantly running into Earth's magnetic field. And this is really great for MMS because we know that at some point MMS is going to encounter this region, and our hope is that since this process is always happening, we're going to get lucky and actually fly right through the magnetic explosion as it's happening. Now on the night side, the situation is a little bit different. So what happens is you have a more gradual buildup of magnetic energy in the tail, and these reconnection processes, these magnetic explosions, can just sort of pop off randomly. We don't really know when it's going to happen or where it's going to happen.
During the MMS mission, scientists will have their first chance to watch magnetic reconnection right as it's occurring. By focusing on the small-scale process, scientists may be able to open the door to understanding what happens on larger scales throughout the universe. Of course, it also will teach us more about giant geomagnetic storms, thus helping us safeguard our home planet.
We hope that it's going to allow us to improve our models so that we can put the right physics in it and actually make predictions about where and when reconnection is going to happen, and this will help us make our space weather models more predictively powerful.
This is Atlas Launch Control, T-minus 1 hour, 14 minutes, 36 seconds and counting. We are now topping off the liquid oxygen on board the Centaur while our Atlas stage continues to fill. All of our activities continue to go well and on schedule. Still targeting a liftoff for 10:44, and weather continues to look very favorable for a launch tonight. T-minus 1 hour, 14 minutes, 9 seconds and counting. This is Atlas Launch Control.
Atlas LO2 at 20%.
Roger.
Step 490, CFA purge has been in displacement mode for 45 minutes.
Roger.
This is Atlas Launch Control, T-minus 1 hour, 10 minutes, 23 seconds, and counting. Joining us now in the Mission Director Center at our console is Jim Hall, who is the MMS Mission Manager for Launch Services Program here at the Kennedy Space Center. Jim has been with MMS for quite some time, coordinating all of the activities that will be going on here both tonight and that have already been completed as far as getting our Atlas stacked and on the launch pad. So, Jim, would like to welcome you. First of all, thanks very much for joining us and giving us a rundown about what has been going on, how we got this Atlas V ready to fly. So, if we could go ahead and roll the tape, and Jim can tell us exactly what we're seeing.
Here you see the arrival back in December of the Atlas Centaur and booster coming from Decatur, Alabama. They're rolling into the ASOC, which is the Atlas Spaceflight Operations Center. In this building, we do the launch vehicle hardware receipt and inspection, horizontal testing is done, and launch control is done in the same building. As soon as they're complete with that, we're rolling, spinning up to now we're in February, coming out to the vertical integration facility with the booster. The vertical integration facility is a 286-foot tall building, and basically it's where the rocket is assembled. We put all the pieces together in that building. The Atlas booster, there's a beautiful sunrise in this beautiful state of Florida. And here we go. Let's get back to the operation at the VIF with the booster. The booster erection process is beginning. As you can see, they're erecting it up onto the mobile launch platform, which is at the base of the VIF there. The Atlas V booster is 12.5 foot in diameter and 106.5 foot in length. It's powered by a Russian-built RD-180 engine. It's a single engine with 2 thrust chambers. The fuel is highly purified kerosene, we call RP1, and liquid oxygen mixture. this gives us approximately 860,000 pounds of thrust at sea level. As you can see in the picture there, we've completed the erection of that first stage booster. The next step is to put on the solid rocket boosters. For this mission, based on the mass of the MMS spacecraft, we required 2 solid rocket boosters. These are built by the Aerojet Corporation. Each one has approximately 380,000 pounds of thrust. And so if you add that stack up on launch day, at liftoff today, we're going to have approximately 1.6 million pounds of thrust going there. We're looking right there at the side of the booster. There's putting on one of the solid rocket boosters there. You can see off on the right there, there's the LOX feed line for the Atlas V booster. Next step is to put the Centaur on. Here's the Centaur coming from the ASOC. Centaur is the upper stage of the rocket. The Centaur is 10 foot in diameter and 41.5 foot in length. The propellant tanks are constructed of a pressure-stabilized stainless steel. The fuel is a cryogenic liquid hydrogen, liquid oxygen. And you've been hearing George's comment on the progress of that fueling operation. These engine on that Centaur is an Aerojet Rocketdyne RL-10A. This engine has a thrust capacity of 22,300 pounds of thrust. So looking at this picture here, we've pretty much got an assembled rocket, but we're missing the cap. And there it is, the encapsulated spacecraft fairing, which has been processing in parallel, and they had an outstanding flow this time down here at Astrotech. There's the encapsulated spacecraft. We put that in our 4-meter extra extended payload fairing, which is 45.3 foot long. We build that fairing out in Harlingen, Texas, and we've got a snug fit with the 4 spacecraft that are 4 foot by 12 foot and stacked in there very snugly. Here's a shot of the final top of the rocket there. Here we go. As we set the encapsulated spacecraft on, there's a technician going in through the boat tail to make sure he's cinching up the final connections to the spacecraft and launch vehicle. Shortly after this, as you can see, we pretty much have an assembled rocket. And the next step here is we tested it, George, and we did that test on the 3rd of March, an integrated system test, and that went very well for us. And here we are today, and what looks to be a clean countdown so far.
Well, Jim, you work sort of both sides of the equation. You work some with the launch vehicle aspect, but also with our spacecraft and our MMS team. Tell me how that interface, how are you able to do that? What's involved in working together with the vehicle and the spacecraft?
Yeah, it's a lot of coordination. We've what we did on our we set up routine tag ups. We've been talking with this spacecraft. We awarded this in 2009, so we've been working with this team for quite some time. A lot of time and effort went into it. So we talk a lot as a team, both the spacecraft side and the launch vehicle team, and we've had a lot of time to go through the flow. So we've got a solid set of requirements, and we've had a lot of time to ensure that our interfaces are all well understood. And it's really been a good camaraderie, great communication, super team effort, and I'm very proud to be part of the team.
Well, Jim, thank you very much. Jim Hall, our Launch Services Program MMS Mission Manager for our launch tonight. Jim, thanks very much.
Thank you.
And we're continuing to press on toward preparations for loading the Centaur with liquid hydrogen coming up in a few minutes. We're at T-minus 1 hour, 3 minutes, 8 seconds and counting. This is Atlas Launch Control.
Atlas LO2 at 50%.
Roger.
T-minus 60 minutes.
AHB's at flight mass.
Roger.
LH2 chill down is complete.
Roger. Start LH2 tanking.
Roger.
ECS, adjust CEM ECS temperature per TRD.
Roger. Atlas LO2 at 60%.
Roger. ECS, initiate BRC ECS.
Roger.
T-minus 55 minutes.
Start flight control, final preps.
Roger.
Atlas LO2 at 70%.
Roger.
Centaur LH2 at 10%.
Roger.
This is Atlas Launch Control, T-minus 50 minutes, 57 seconds, and counting. As we've heard, loading the Centaur with liquid hydrogen is now underway. The last major step in fueling our Atlas V launch vehicle this evening. And we've just confirmed that we're at about 20% liquid hydrogen on board the Centaur. We'd like to welcome now Vern Thorpe, who is the program manager for NASA missions from United Launch Alliance, and he's going to talk some about the flight of the Atlas V. First of all, Vern, from your perspective, how's the countdown been going tonight since we picked up earlier?
Oh, it's been very smooth. We've got a clean launch vehicle. We've got a clean satellite. The weather has been cooperating so far, so this is about as good as it gets right now.
That's good. There's a lot of people watching along the Space Coast tonight hoping this is going to happen. And we've got a video now. We've just seen Jim Hall from Launch Services Program talk us through some of what's been going on to get the Atlas V ready for launch tonight. Maybe you can tell us now what happens after liftoff.
Yeah, I'd be happy to do that. Why don't we go ahead and roll that video. So you see here the configuration that we're using tonight lifting off. We have an Atlas V booster with 2 solid rocket boosters on it to help give it a little extra thrust. So it'll lift off with about 1.5 million pounds of thrust. And as it ascends, the first major event that you're going to see will be the burnout of those 2 SRBs. Those will burn out, and then we'll jettison them about 1.5 minutes into flight. Now we'll keep burning the propellants in that core stage for about 4 minutes. Then we'll shut down the engine and separate from the Centaur upper stage, as you see right here. We'll spend a few seconds preparing that engine for the first of 2 burns, and then we'll light that engine. The first engine burn of the Centaur upper stage will last just over 9 minutes tonight, and very early in that first burn we'll separate the payload fairing. Now after that first burn is complete, we'll enter a parking orbit coast for almost an hour. It's a 59-minute parking orbit coast. Then we'll burn the engine a second time for about 5 minutes and 40 seconds, and that will place us in the orbit that we want to get to for those 4 spacecraft. Once we are in that final orbit, we'll point in the right direction, take a few moments to stabilize the vehicle, and then we'll begin a series of 4 separations of those MMS spacecraft. We'll separate the spacecraft at 5-minute intervals, and while we're in between those separations, we're going to hold the Centaur very stable for about a 20-minute period. We will actually lock up the tank vents and do a few other things to minimize disturbances so that there is as little disturbance as possible between each of those separations that are 5 minutes apart. And once we're done with those separations, we'll do the usual contamination and collision avoidance maneuver that we always do to make sure there's no chance of recontact, and the mission will be complete. The first spacecraft will separate about 1 hour and 32 minutes into flight, and the 4th one will be separated by 1 hour and 47 minutes into flight.
Well, United Launch Alliance has a fairly full agenda this year, just beyond the NASA missions, and I think there's one coming up before too long, is there not?
We do. We have another mission coming up a couple of weeks from now, and I think in total we have 13 missions on our manifest this year. The launch tonight will be the 3rd one of the year, and this will actually be the 94th mission that we've flown since ULA formed a few years ago, so 94 missions in just over 8 years.
Well, Vern, thanks very much for stopping by, and of course we're looking forward to this one in particular. As we heard, a lot of our MMS science team has been working this for quite a long time, and this is certainly a significant launch for United Launch Alliance. So thanks very much.
Okay, my pleasure, George. Thanks.
Now we're at T-minus 46 minutes, 51 seconds and counting. This is Atlas Launch Control.
Centaur LH2 at 50%.
Roger.
Step 600 ECB at flight pressure.
Roger.
Centaur LH2 at 60%.
Roger.
Centaur LH2 at 70%.
Roger.
Atlas LO2 at 90%.
Roger.
T-minus 43 minutes. T-minus 42 minutes.
Centaur LH2 at 80%.
Roger.
Centaur LH2 at 90%.
Roger.
T-minus 40 minutes.
Start final open loop FTS test.
Roger. Atlas LO2 at 97.5%, topping started.
Roger.
Centaur LH2 at 96.2%, topping started.
Roger. Perform Centaur LH2 fill and drain valve cycle test.
Roger.
Perform Centaur LO2 fill and drain valve cycle test.
Roger.
This was Atlas Launch Control, T-minus 36 minutes, 47 seconds and counting. Bringing to a conclusion the fueling of our Atlas V Atlas Centaur rocket, which has been going very smoothly. And at this time, we'd like to recognize NASA's Dr. Philip Tang, who passed away late in February. He worked for the Launch Services Program at Kennedy Space Center and had been at Kennedy more than 25 years
Centaur LH2 fill and drain valve
many different roles and assignments. At the time of his passing, he was supporting payload electrical work for the MMS mission being launched tonight. He had also most recently supported NASA's OCO2 and SMAP launches from Vandenberg Air Force Base in California. The fill and drain valve cycle test has just been successfully completed, which keeps us on track in our countdown procedure and toward a launch at 10:44. Right now we're at T-minus 35 minutes, 35 seconds and counting. This is Atlas Launch Control.
T-minus 35 minutes.
Atlas LO2 at 99.6%.
Roger. Cycle Atlas LO2 fill and drain valve.
Roger.
Perform Atlas Airborne LO2 vent valve functional test.
Roger.
Centaur SRV and LH2 SVV cycle tests are complete.
Roger. Resume Centaur LH2 topping to flight level.
Roger.
Resume Centaur LO2 topping to flight level.
Roger.
Flight control perform Centaur PU functional test.
Roger.
T-minus 31 minutes.
This is Atlas Launch Control at T-minus 27 minutes, 55 seconds and counting. Upon liftoff, tracking of the Atlas V rocket will be done by the Air Force Eastern Range, beginning with the antennas here at Cape Canaveral Air Force Station and the Kennedy Space Center. At 49 seconds after liftoff, the Air Force Downrange Station near Jupiter Inlet in South Florida will also acquire the rocket until it loses signal about 8 minutes and 3 seconds after launch. At that point, coverage transitions to TDRS. The TDRS East Tracking and Data Relay Satellite will be first. As the rocket approaches the far side of the Earth, the Indian Ocean TDRS will be furnishing data, followed then by TDRS West over the Pacific Ocean. on the ground supporting the spacecraft for the 4 spacecraft separation deployments as they occur will be tracking stations in Hawaii, Vandenberg Air Force Base in California, and the New Boston tracking station in New Hampshire. After liftoff, we'll hear the voice of Marty Malinowski, our United Launch Alliance flight telemetry engineer, calling the Atlas V launch vehicle events as they occur. At T-minus 26 minutes 30 seconds and counting, this is Atlas Launch Control.
T-minus 26 minutes. T-minus 25 minutes.
LC or F? Go ahead, RF.
LC step 850. The FTS open test is complete.
Roger.
LCALO.
Go ahead.
Atlas LO2 fill and drain valve cycle test is complete.
Roger.
Atlas airborne vent valve functional test is complete.
Roger. Perform pogo suppressor charge.
Roger.
This is Atlas Launch Control, T-minus 21 minutes, 38 seconds and counting. Once the Atlas V lifts off, the Atlas and the Centaur together will burn initially for a total of 13 minutes and 29 seconds. And at that point, after the Centaur cuts off, there will be a coast phase that is fairly lengthy, about 58 minutes and 58 seconds. After the coast phase is complete, there will be the second burn of the Centaur, which lasts 5 minutes and 41 seconds, and then an unusually long burn before the spacecraft separation starts. There'll be a second coast phase lasting at about 14 minutes. And most of that time, our data will be coming through the tracking and data relay satellite system, but also once we begin the spacecraft deployments, of which there will be 4, we'll be getting data as well from Hawaii, Vandenberg Air Force Base in California, and the New Boston station in New Hampshire. The RP-1 fuel on the Atlas stage was loaded aboard early yesterday afternoon, starting at about 1:25, and was completed about an hour later at about 2:45.
T-minus 19 minutes.
Atlas Propulsion, perform RD-180 transducer converter calibration.
Roger.
LCALO.
Go ahead.
Step 720, pogo suppressor charge complete.
Roger.
This is Atlas Launch Control. We're now at T-minus 18 minutes, 18 seconds and counting, proceeding toward an on-time launch at 10:44. Our weather continues to look excellent at this point. We will be getting a weather briefing from our launch weather officer, Clay Flynn, in about 20 minutes at 10:14.
Roger.
Continuing not to work any issues either on the Atlas V or on our 4 MMS observatories atop the rocket. At T-minus 17 minutes, 38 seconds and counting, this is Atlas Launch Control.
LCCLO.
Go ahead.
Centaur LO2 at flight level.
Roger.
T-minus 17 minutes.
Engine FIV is closed.
Roger.
T-minus 16 minutes.
Initiate fuel fill sequence.
Roger.
T-minus 15 minutes.
LC Flight Control Channel 1.
Go ahead.
Flight Control final preps are complete.
Roger.
T-minus 12 minutes.
This is Atlas Launch Control, T-minus 8 minutes, 40 seconds, and counting. Liquid oxygen has been loaded aboard the Centaur, about 4,200 gallons, and hydrogen is being loaded to a total of about 12,700 gallons. The RL-10 engines on the Centaur burn a combination of liquid hydrogen and liquid oxygen, while the Atlas booster stage burns a combination of RP-1, a highly refined kerosene, and liquid oxygen. Once the MMS observatories are operational, they will be flying a highly elliptical orbit, about 44,000 by 95,000 miles away from the Earth, about nearly halfway to the Moon. But yet they will be, some of them, flying as close as just 6 miles apart from each other in that tetrahedron formation. The mission is going to advance our knowledge of space and solar physics, but yet have some very practical applications, such as understanding the effect of what causes solar storms and predicting the timing and severity of their effects on Earth and how best to respond to them. The communications channels here in the Mission Director Center are very quiet. There's nothing unusual at all going on. And the next thing coming up here of note is the weather briefing in about 8 minutes. At T-minus 6 minutes, 8 seconds and counting, this is Atlas Launch Control.
T-minus 6 minutes.
Fuel fill sequence is complete.
Roger.
T-minus 5 minutes.
Start RADAS data acquisition.
Roger. Atlas LO2 at flight level.
Roger.
Centaur LO2 at flight level.
Roger.
Centaur LH2 at flight level.
Roger.
This is Atlas Launch Control, T-minus 4 minutes, 30 seconds and counting. Standing by to go into our planned 30-minute built-in hold at T-minus 4 minutes, coming up in about 20 seconds. Again, this has been a very smooth countdown for us. Standing by now to go into the hold in 5, 4, 3, 2, 1. T-minus 4 minutes and holding.
Program 30-minute hold.
This is a planned 30-minute built-in hold. This is one that allows the launch team to catch up on anything on which they're behind or to work any issues, but right now there aren't any.
All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
LC flight control on channel 1.
Go ahead.
Yes, sir. Step 1060. Primary address text hex file address AV053_05 with SDL-CRC of 10 Delta 3 has been received, verified, and is ready to load into the FTINU.
Proceed with load.
Roger.
Right now they're loading upper level wind data into the flight guidance system on board the Atlas. Everyone on the launch team now is on the same channel, the primary channel for the terminal count, channel 1, which the launch conductor has been conducting this launch countdown today. Launch weather briefing coming up here in a couple of minutes. About a half an hour just prior to coming out of the built-in holes. We'll have a poll from our NASA launch manager, Omar Baez, of the full NASA launch team, including the MMS spacecraft payload test team. Less than a minute away from hearing our launch weather officer Clay Flynn from the 45th Weather Squadron to give us a final weather briefing for launch.
Monitor.
Go ahead.
Step 1170, red line monitor and event table are in the correct configuration for terminal count.
Roger. RC, conduct weather briefing on Channel 8 Weather Conference Net.
Roger. LWO, Range Coordinator Channel 8.
LWO.
LWO, please stand by for weather brief on Channel 8.
Standing by.
Following personnel, acknowledge standing by on Channel 8 for weather brief. NLM.
NLM.
LD.
LD is on.
AFLD.
AFLD.
LWO, please proceed with your brief.
Yes, sir. Looking at the, this is LWO on CC Local at Channel 8 and Weather Brief Net. Looking at your peninsula of Florida there, your satellite picture, you know we do have some low cloud dips down to the south that should remain south of us for during the window. Even if it were to be over the pad, it's not a concern in terms of LCC violation. Tops on that cloud, the tops on those clouds are about 6,000 feet, so not a concern if they did push up over the pad. To the north, we do have denser cirrus streaming to the north. Over for the pad. We just have relatively thin cirrus and not a very small concern with any type of LCC violation for the balance of the count and the window. Taking a look at the radar, no echoes approaching complex 41 well south, 50 miles south or so, so very low likelihood of any type of cumulus cloud roll violation or a thick cloud roll violation for the balance of the count and the window. Looking at the winds out of complex 41, winds did peak up just a bit. The peaks are 22 knots, the highest we've seen at about 450 feet or 24 knots. So I think this is about the tops that we'll see during the window gust at 22 knots. In terms of the direction, they are essentially straight out of the east, about from 95 degrees on that order, varying between 90 and 100 degrees, but about 95 degrees. Temperature is 73 and won't see any significant change in that for the balance of the count in the window. And this is a composite of the number of the balloons. We did lose that little higher winds that we had here in the 5 to 7,000 foot range, but otherwise not a significant change in terms of the speeds, other than in the lower couple thousand feet we did increase in speeds. In terms of the ops forecast, really no change in the forecast, other than did bump up the winds from 100 degrees, 18 gusting to 22. Otherwise, scattered low clouds and thin cirrus at 28,000 feet, broken deck at 28,000 feet. Low likelihood of any type of coastal shower, 73, and a 10% or less chance of any type of violation for the balance of the count and window. All LCCs are go, expect to remain go. No change in the 24-hour delay. Proton flux remains at normal background levels. And this concludes the weather brief. Pending your questions, sir.
Range coordinator has no questions.
LD, no questions.
NLM, no questions.
AFLD, no questions.
OSM, LC, net 1.
This is OSM.
Place SRB ignition SNA switch in the enable position.
SRB ignition enabled.
OSM, verify the FCO, RCO, and OSM home fire switches are in the proceed position.
Ready to proceed.
This is Atlas Launch Control, T-minus 4 minutes and holding. 22 minutes, 22 seconds remaining this plan build and hold. As we heard, we have just a 10% chance of having a launch weather issue. We're 90% go. Not working any other issues on the Atlas V, on the Eastern Range, or with our 4 MMS observatories atop the Atlas V rocket. At T-minus 4 minutes and holding, this is Atlas Launch Control. This is Atlas Launch Control, T-minus 4 minutes and holding. Next major activity for the MMS is to begin going to internal power. Process starts at about launch minus 12 minutes, and by launch minus 9 minutes they should have that process complete and will confirm that the spacecraft is on internal power. Our communications channels continue to be rather quiet. Here in the Mission Director Center, no issues being worked, everything going exactly by the timeline. We have an on-time liftoff planned for 10:44 p.m. At T-minus 4 minutes and holding, this is Atlas Launch Control. This is Atlas Launch Control, T-minus 4 minutes and holding. Standing by in about 2 minutes for our final launch readiness poll from our NASA launch manager, Omar Baez, who will be polling the NASA launch team as well as the spacecraft team for their readiness to go for launch tonight. And he will pass that readiness off to our Atlas V launch conductor, Doug Lebo.
RFFPS LC.
SRF.
Established Davis system and cameras are configured for launch.
Roger. Davis system cameras configured for launch.
Roger. Flight control, perform launch on time verification.
Roger.
This is the
LC,
NLM on the
range.
NLM net for NASA's final launch readiness poll. NASA CE.
NASA CEs go.
SMA.
SMAs go.
SMD.
SMD is go.
NASA Mission Manager.
NASA mission manager is go.
NAM.
NAM's ready.
Copy that. NASA team's ready for launch.
This is Atlas Launch Control, T-minus 4 minutes and holding. NASA launch manager Omar Baez confirms the NASA team is ready for launch tonight. There are
Flight control channel 1.
3 cameras on the Atlas V that we'll be seeing tonight. The Atlas has an aft-facing camera. Atlas aft-facing camera that you're seeing right now actually is going to be able to be seen for the entire duration of the Atlas burn. There will then be a Centaur aft-facing camera as well on the second stage, the upper stage facing aft, that we'll see for part of its burn. And there is also a Centaur forward-facing camera that will be sending back data but on a delayed basis, so we will not see that in real time. But the Atlas first stage aft-facing camera we'll see at liftoff and continuing through the initiation of the Centaur second stage burn as well. Confirmation now that the MMS spacecraft is being transitioned to internal power. That operation now is in work. At T-minus 4 minutes and holding, this is Atlas Launch Control.
This is the LC with terminal count briefing. If a condition exceeds a launch constraint anytime after the terminal count status check, The observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold. RC, verify solar radiation acceptable for launch.
Verified.
LC switch to ready position.
All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
All steps are complete prior to the status check.
Have confirmation that the 4 MMS observatories are now on internal power. That will be passed to our launch conductor, Doug Lebo. NASA Launch Manager Omar Baez has just advised ULA Launch Director Bill Cullen that NASA is go for launch.
Status check to proceed with terminal count. Atlas Systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur Systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
Com.
Go.
Timer.
Go.
GC cube.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. T0 is planned for 02:44 Zulu. Set count to start at 02:40 Zulu.
Roger. T0 is set for 0244 Zulu. Count will start at 02:40 Zulu.
And we're about 2 minutes now from picking up the countdown.
NSC, verify spacecraft is on internal power.
Spacecraft is on internal power.
All steps are complete prior to terminal count.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
3:55.
Ground pyros enabled.
T-minus 3 minutes. 3 minutes and counting.
Atlas tanks to flight pressure.
250.
FTS internal.
T-minus 2 minutes and counting. 2 minutes to launch.
159.
Vehicle internal.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
FTS armed.
$120.
FCS
Clock
count
is up.
started.
$110.
Vent valves locked.
60 seconds.
Rock, report range status.
Range green.
T-minus 45 seconds and counting.
40.
Stable at step 3.
T-minus 30 seconds.
25.
Status check.
Go Atlas.
Go Centaur.
Go MMS.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5. Go for main engine start. 3, 2, 1, 0. And liftoff of the Atlas V with MMS, using magnetic reconnection to fill in pieces of the puzzle of space weather.
Phase of flight. And booster throttle back. Roll program is completed. Mach 1. Excellent.
well. SRB chamber pressures have rolled off. Current altitude is 0.46 miles, downrange distance 4.1 miles, velocity 1,882 miles per hour.
Stationed at Jupiter Inlet now supplying data.
SRB chamber pressures continue to look good, coming up on SRB burnout. RD-18 continues to operate well. We have chamber pressures rolling off. And we have satisfied VODA, and we have throttled back up to 100% thrust. Current altitude is 19 miles, downrange distance 18.7 miles, current velocity 3,028 miles per hour.
Atlas will cut off at 4 minutes and 9 seconds into the flight.
RD-18 continues to perform well, pump speeds and chamber pressures within band. Coming up on closed loop steering. And we have enabled closed loop steering. The V's have been jettisoned. We have performed a roll bias maneuver.
All the data looks good coming back to the Mission Director Center.
RCS pyro valve has been fired. That system is now pressurizing to flight levels. Signatures look good. Alpha limited steering has been enabled. Current altitude is 44 miles. Downrange distance is 114 miles. Current velocity is 7,155 miles per hour. Currently accelerating smoothly at 3.5 Gs. Coming up on our 5G throttle segment. And booster has begun to throttle to maintain 5 Gs. Boost phase cooldown is underway. And booster has begun to throttle to 4.6 Gs in preparation for PICO.
Standing by for booster engine cutoff.
And we have engine shutdown.
Engine shut down right on time.
We have fired the retros and have clean stage separation. We have box and fuel pre-start on the RL-10. GN2 purge firing on the RCS is underway.
Standing by for Centaur
We
engine
have
start.
ignition and full thrust on the RL-10.
Centaur is burning.
And we have indication of payload fairing jettison. Looks like a clean jettison. Centaur steering has been enabled. Tank pressures are being reduced at this point of flight. Centaur PU has gone to fixed angles for the early portion of this 9-minute and 7-second burn. RCS line temperatures are warming toward throttle temperature. Signatures look good. RL-10 performance looks very good. Chamber pressures, box pump discharge, and fuel venturi are all within the expected region for the wet mixture ratio.
All the data coming back into the Mission Director Center is in the green.
Centaur is currently flying at an altitude of 113 miles. Downrange distance is 600 miles. Current velocity is 12,919 miles per hour.
Six minutes into the flight.
Centaur PU is now operating in a closed loop fashion, however, it's continuing to request an oxidizer-rich condition. Quick look at the booster performance shows we were plus 52 pounds mass, which is 1/2 sigma positive. And Centaur has begun its roll to Tidris attitude. And we have had the format change, just a minor loss of data at that point. RL-10 continues to perform well. First chamber, box pump discharge, and fuel venturi all within expected range. Centaur PU has now come off the box-rich stop. Centaur has now achieved the earliest head-on gate time. Range track shows it is beyond the range for the head-on gate. Continue to make good progress down the middle of the corridor.
Loss of signal at Jupiter Inlet, and we are now on Tidris East.
Current altitude is 142 miles. Downrange distance is 1,002 miles. Current velocity is 13,677 miles per hour. Centaur has now switched to antenna select mode. Continuing to see our normal thermal conditioning firings on the reaction control system. Line temperatures have nearly warmed to bottle temperatures. Tank pressures are stable. Storage bottle pressures look good. Battery voltages also look good.
Eight minutes, 30 seconds into the flight.
Five minutes remain in this burn. All Centaur systems look very good at this point. Currently, Centaur is flying at an altitude of 149 miles. Downrange distance 1,295 miles. Current velocity 14,380 miles per hour. And Centaur PU is now controlling near nominal. RL-10 performance is within band for the set mixture ratio. Pump temperatures look good.
Four minutes remaining in this Centaur burn. Launch plus 10 minutes into the flight.
Centaur tank pressures are stable. Storage bottle pressures continue to look good. Battery voltages do as well. PU has nearly worked off all the excess oxidizer. RL-10's performing well. Thrust chambers, box pump discharge, and fuel venturi look good.
3 minutes remaining in the Centaur burn.
Centaur continues to perform nominally, currently flying at an altitude of 145 miles. Downrange distance is 1,848 miles. Current velocity 15,794 miles per hour.
Two minutes remaining in this Centaur burn.
Two minutes remain in this burn. RL10 performance continues to look excellent. Having very good data quality. RCS line temperatures have warmed to bottle temperatures. Continuing to see our thermal conditioning firings.
"12 minutes into the flight.
Centaur continues to perform well. Current tank pressures are stable. Storage bottle pressures look good. Body rates are the same and continue to control right down the middle of the range corridor.
About 45 seconds remaining in the first burn of the Centaur. "13 minutes into the mission.
And we have IIP vanished. Centaur is now orbital. RL10 performance continues to be nominal. RCS continues its thermal conditioning firing. And we have MECO. Engine shutdown looks good. We have 4S settling on. Tank pressures are stable. Fuel tank has been vented down. Storage bottle pressures are stable as well. Centaur has begun its turn to PTC attitude. Begun its roll at 1 degree per second. This coast period is expected to be 58 minutes and 58 seconds in duration, prior to our second burn, which will be 5 minutes and 40 seconds in duration.
And we'll look now at some launch replays from different camera angles and cameras around Kennedy Space Center in Cape Canaveral of tonight's liftoff. 8, 7, 6, 5. Go for main engine start. 3, 2, 1, 0. And liftoff of the Atlas V with MMS, using magnetic reconnection to fill in pieces of the puzzle of space weather.
And Centaur continues its 4S settling at 12.5%. Tank pressures remain stable. Storage bottle pressures look good. Continuing to roll at -1 degree per second.
This is Atlas Launch Control, now 36 minutes, 25 seconds into the flight of the Atlas V with MMS. Vehicle is in its planned coast phase, and all things are showing normal on the Centaur. And also the Spacecraft MMS team is in contact with the 4 MMS observatories, and they are also sending back data indicating that they are also all in good health as well during this portion of the launch. Next activity is going to be the second burn of the Centaur engine restart, which occurs at 1 hour 18 minutes 11 seconds into the flight. So there is a 58-minute, 58-second coast phase now going on. And in the interim, we will continue to monitor whatever audio comes from our flight telemetry engineer, Marty Malinowski, who is monitoring the Centaur. But at this point in the coast phase, it is very quiet until we get within about 5 minutes or so of the Centaur engine restart. That burn will last a little over 5 minutes. So our coverage is going to resume at 11:50 p.m., about a half an hour from now. At 38 minutes, 4 seconds into the flight of the Atlas V with MMS, this is Atlas Launch Control.
A little over 3,900 seconds into the mission. Centaur is cruising at an altitude of 358 miles, downrange distance 15,877 miles, current velocity 16,687 miles per hour. Centaur is now settling at a 50% duty cycle. Signatures look good. Tank pressures continue to be stable. Storage bottle pressures look good, and battery voltages do as well.
This is Atlas Launch Control, 1 hour, 6 minutes, 48 seconds into the flight of the Atlas V with MMS. Right now, the Centaur stage continues in its coast phase, the duration of which is 58 minutes and 58 seconds. Once the Centaur restarts for the second burn at launch plus 1 hour, 18 minutes and 11 seconds, it will burn for just over 5 minutes. While we've been in the coast, the 4 MMS spacecraft have been sending data back through the Tracking and Data Relay Satellite System. And as we approach the location for spacecraft separation, we'll be getting support from the ground also from the Hawaii station first, which acquires at launch plus 1 hour 16 minutes in about another 8 minutes from now. And as they cross the Pacific, the Vandenberg Air Force Base tracking station will acquire in California. And finally, the New Boston station located in New Hampshire at 90 minutes, an hour and a half into the flight. As the Centaur reorients for the restart of the Centaur upper stage, there will be a loss of signal that the 4 MMS spacecraft will experience. So the spacecraft team is preparing for that loss of signal during the reorientation and the preparation for the Centaur engine restart. So with the flight continuing to go smoothly, we're at launch plus 1 hour, 9 minutes, and counting into the mission toward our spacecraft separation. This is Atlas Launch Control.
And Centaur has begun its D-spin in preparation for MES 2. And Centaur is completing its turn to optimize telemetry. Still making its turn to the MES-2 attitude. And Centaur has achieved the MES-2 attitude, still settling at a 50% duty cycle on the 4S motors. And now we have gone to a full 100% duty cycle. Tank pressures are being increased in preparation for MES-2. And we've gone to dual branch pressurization. 1 minute to MES-2. Fuel pre-start is underway.
This is Atlas Launch Control. Launch was 1 hour, 12 minutes into the mission. We're less than a minute away from Centaur restarting.
LOX pre-start is underway. We have ignition and full thrust on the RL-10. This burn is planned for 5 minutes and 40 seconds in duration. Centaur PU has been enabled. It's requesting an oxidizer-rich condition at this point. Chamber pressures are unbanned. LOX pump discharge and fuel venturi look good. Centaur is accelerating smoothly at 0.65 Gs. Still commanding an oxidizer-rich condition. Tank pressures look good. Storage bottle pressures do as well. Battery voltages are stable. Seeing RCS thermal conditioning firing, signatures look good. Line temperatures are at bottle temperature. PU has come off the oxidizer-rich stop. Engine response looks good for the set MR. Centaur is currently accelerating at 0.7 Gs. RL-10 continues to perform well. Chamber pressures right in band. Controlling near nominal mixture ratio at this point. And PU has corrected out all the excess oxidizer, controlling at nominal MR. RL-10 chamber pressures within band. LOX pump discharge and fuel venturi look good. Tank pressures being ramped up.
About 2.5 minutes remaining in this Centaur second burn.
Centaur continues to perform well. RL10 is right in band for all engine parameters.
After the Centaur cuts off, we'll be entering another coast phase that will last about 14 minutes before we have the first spacecraft separation.
EU continues to control at nominal MR. Engine performance looks very good. Currently accelerating at 0.91 Gs.
About a minute remaining in this Centaur second burn.
Centaur now accelerating at 1 G. RL10 performance continues to be excellent. Centaur PU is at fixed angles in preparation for BECO. And we have MECO. Engine shutdown looks good. 4S settling is begun. Fuel tank has been vented down and pressures are now stable. Centaur has begun its maneuver for the tank quench. Centaur has begun a 50% 4S duty cycle. Signatures are as expected.
Coverage coming through both Tidris West and
Fuel
Hawaii.
tank levels are being vented down. And the vent is complete. Tank pressures are stable. And Centaur continues its quench maneuver. And a look at the MECO 2 plus 3-second open shows all the orbital parameters are very close to the pre-flight predictions. Centaur is right where we expected it.
Vehicle should be in the proper attitude for signal acquisition by the MMS spacecraft momentarily as the Centaur reorients itself for spacecraft
Centaur
separation.
is in its PTC roll of 1 degree per second.
Telemetry now being picked up through observatory number 4.
And Centaur has completed the turn to be orbit normal. Still rolling at plus 1 degree per second.
Passing over Hawaii now, and Vandenberg Air Force Base in California also about to acquire.
Centaur has begun the turn to the MMS 4 separation attitude. And Centaur's continue its PTC roll at plus 1 degree per second as it reorients to the MMS 4 separation attitude.
Centaur will be spinning up to 3 RPMs for separation.
And Centaur has completed its turn to the MMS 4 separation attitude, continuing to roll at 1 degree per second. This is a 0G coast period with no settling in play.
MMS number 4 will be the first one to separate about 7 minutes from now. At 1 hour and 32 minutes into the mission.
We have indication that we have propellant at the forward bulkhead. As Centaur continues this zero-G coast phase, tank pressures remain stable, still rolling at 1 degree per second. All systems look good.
And we're about 5 minutes away from spacecraft separation, or at least our first spacecraft separation, MMS 4.
Centaur continues this zero-G coast phase. All systems are stable. Tank pressures look good. Storage bottle pressures are stable as well.
Spacecraft support now coming from Tidris West through Hawaii and from Vandenberg Air Force Base.
Begun its D-spin from its PTC roll. And Centaur has gone to 4S settling to resettle our propellants after our zero-G coast phase to quench the tank sidewall. Centaur has now completed the D-spin, continuing to settle at 4S, 100% duty cycle. And Centaur has begun to ramp the 4S settling motors to a 50% duty cycle. Signatures look good. and we've begun the spin up for MMS 4 separation. Centaur will spin up to 18 degrees per second prior to separation. Currently spinning at 6 degrees per second.
Less than half a minute away from spacecraft separation for MMS 4.
Degrees per second.
There we can see the spin up underway.
16 degrees per second. (18 degrees per second), and we have MMS 4 separation.
Applause here in the Mission Director Center for the first separation of MMS 4. MMS 4 is on its own.
And
spacecraft data shows as well that it has separated.
Centaur has despun from its 18 degrees per second.
5 minutes between each of the spacecraft separations, so we got less than 5 minutes now before MMS number 3 separates. Spin rate 3.02 on MMS 4. Telemetry from MMS 4 looks good.
Centaur continues its zero-G coast to the separation event. It will also spin up to 18 degrees per second for MMS 3 and all following separations.
We're about 2 minutes away now from MMS 3 separation.
And a look at the MMS 4 separation open. Shows good agreement with the pre-flight predictions. Approximately 38 kilometers low on apogee height and right on perigee radius. Centaur has begun the spin up for the MMS3 separation. Five degrees per second.
50 seconds away now from spacecraft separation of MMS3. Telemetry coming back from MMS3. Spin up underway.
$15 degrees per second. $18 degrees per second, and we have MMS3 separation.
And
Centaur has begun its
MMS3 is away. Spacecraft telemetry confirms separation.
D-spin.
About 3 minutes away now from separation of MMS2.
Centaur tank pressures and bottle pressures remain stable. Battery voltages look good. Coming up on the next spin-up event, approximately another minute. And Centaur has begun the next spin up for MMS2. Five degrees per second. Ten degrees per second.
24 seconds away from separation of MMS2.
Fifteen degrees per second.
Spin up underway.
$18 degrees per second, and we have MMS2 separation.
And MMS2 is away.
Centaur is now despinning.
Five minutes away
Centaur
before
continues its
MMS
zero-G
number
coast,
one.
has now despun.
Telemetry looks good from MMS number two.
And a look at the open for the MMS3 separation. Again, shows very close agreement in the actual measured trajectory with the pre-flight predictions. Looks like a very good orbit. Tank pressures remain stable. Throttle pressures look good.
MMS number two spinning at 3.4 RPM according to the telemetry data. Data coming through the Tetris West spacecraft. We'll be transitioning
About
to
another minute
Tetris
until we spin
East.
up for the final MMS separation. Centaur remains stable at this point in its zero-G coast.
And spacecraft telemetry data also through the New Boston station in New Hampshire. As the Centaur begins to fly off the east coast.
And Centaur has begun the spin up for the final MMS spacecraft separation. Five degrees per second. Ten degrees per second.
Less than a minute away from separation of MMS number 1.
$15 degrees per second. $18 degrees per second, and we have MMS1 separation.
And there is separation of MMS1.
Centaur has begun its D-spin. And Centaur has completed the D-spin.
And that brings the flight of the Atlas V to a completion with the separation of the last of the 4 MMS spacecraft. Standing by for data through the MMS-1 spacecraft is its state of health. But all indications are that we've had a nominal final spacecraft separation event. Terminal data from MMS-1 looks good. Still rating on the spin rate. And the spin rate is 3.01, right on the money.
And Centaur continues to coast in a zero-G fashion, waiting to gain enough separation to begin its CCAM maneuver.
We're now an hour and 50 minutes into the flight of the Atlas V with MMS, which has separated its 4 spacecraft. And now joining us here at the console in the Mission Direction Center is Omar Baez, who was our NASA launch man for tonight's launch. And Omar would like to kind of discuss how the countdown, how the flight went, and first of all, the countdown itself, how did that seem to go for you?
Hey, George, the count today went really well. We very quiet. We really worked absolutely no launch vehicle issues or spacecraft issues. The range was green, and just nothing of any significance as far as a countdown, just picture perfect, and the flight was nominal. We got separation on time for all four. It looks like they're in the intended orbit that we planned for. So picture perfect. It was
flight went well as well after liftoff.
Flight went well. Everything. I mean, through separation, they're in the orbits they need to be. The four MMS spacecraft, and very unique here. We usually get one set of claps for, and here we had four. So kind of
claps. That's right.
So everybody's cheering, and it appears that all four are where they need to be. Can't ask for any more.
Well, that's good. We've got another Atlas 5 coming up, I guess. Next one will be out of Vandenberg, I guess. Is that right?
Next one will be the InSight mission out of Vandenberg, going to Mars.
That's a Mars lander. That's correct. So, well, Omar, thanks very much. Congratulations on a good countdown, a quiet countdown, and a very good flight.
Thank you, George. I appreciate the team for this was really a hard mission to put together, and there's some complexity here with this mission, and the team really made it look easy, and it's not.
Especially with four spacecraft, it doesn't it seems like it's one, but it was really four.
Yep.
Well, we're now 1 hour 53 minutes into the flight, and in just a moment we're going to have Craig Tooley come over, who's our mission director or our spacecraft project manager for MMS, and tell us how the four MMS observatories look now that they're on orbit. So we'll be back in just a couple of moments. But Omar, thanks again for coming over and giving us a status on the flight of the Atlas. And in just a minute, we'll get a status on the 4 MMS.
Yep.
We're 1 hour 53 minutes 33 seconds into the flight of MMS. This is Atlas Launch Control. This is Atlas Launch Control. Launch plus 1 hour, 57 minutes, 20 seconds into the mission of MMS. And joining us now is Craig Tooley, the project manager for MMS. And Craig, as Omar pointed out, this was not all that easy. I mean, this was like launching 4 satellites, which it was, instead of just one. But maybe you can tell us, having seen some data now from all 4 of them, how they look and how this seems to have gone.
Sure, certainly. Well, this evening unfolded essentially perfectly for us. The launch, as anyone who watched, was right on time. And then after the Centaur delivered us to exactly where we wanted to be in orbit, and we just completed the deployment of the 4 MMS observatories. They were spun up to the 3 RPMs, and that was right on target. The spin rates, the attitude, it was essentially a flawless delivery of our 4 satellites into the beginning of their formation flying. So we're very happy with that. As we separated them, they in turn, we talked to them through the Tejas ground stations, and they're all healthy and turned on. Essentially, we're all green and headed into our mission.
So what's next for each of the spacecraft now that they're on orbit, and what will you be watching for?
Well, what's next is in about 7 hours, the first thing we'll do is we will test our propulsion systems. We fire the thrusters for a very short period to make sure we know what their performance is, and that's really in preparation for the next thing we'll do in about a day, and that is to adjust the perigee of the orbit. So each of them will do a maneuver about a day from now where we trim out the orbit as planned, and that really starts us off in our mission. Then over the next days, and really stretching over the next days through the next almost 6 weeks, we begin the process of deploying those many booms that we've talked about before. So we have a little while before we're fully configured, but right now we have a healthy flying spacecraft.
So nominally, the scientists involved in this will look forward to getting some data back that they can really sink their teeth into. About when?
Well, they'll start getting data. Some of the instruments will start getting data, within the next few weeks as we turn them on. But actually, over the next 6 months, we commission and calibrate those instruments while we are waiting for them to pass into the region of interest in the magnetopause in the front. So they'll get data very quickly. They won't be flying in the region where they're targeting to capture magnetic reconnection, but some of them will be getting data within the next few weeks as we carefully bring on the instruments and then turn the high voltages up on the various instruments.
Well, Craig, thank you very much, and congratulations on what's now off to a very happy start on your mission. So
thank you
so much. It's been a pleasure to have you with us and working with you over the last couple of months. And we're now at 2 hours 44 seconds into the flight, now the mission of MMS. So we will now conclude our launch coverage for the launch of the Atlas V and our 4 MMS observatories. This is Atlas Launch Control.